Morning, all of you. You know very well that I am Dr. Shaukat Ali, your teacher, going to teach you organic chemistry this semester. This is the first time I am handling organic science for you people. Before I proceed my discussion into the main topic, that is organic science, I hope all you have received your syllabus. You know very well, as usual, in the first and second semester. This semester also have 5 different units. The topic I am going to teach you comes under unit number 2. All the entire concept what we have in unit number 2, I am going to discuss. Plus unit 5, few chapters from unit 5 also I am going to discuss. Unit 2, the subject we are going to, the subject we are going to discuss now is aromatic electrophilic substitution reactions. Let me write what is aromatic electrophilic substitution reaction. Aromatic electrophilic substitution reaction. This is the concept I am going to discuss in this classroom. Aromatic electrophilic substitution reaction. Just have a look in this particular topic. Aromatic. The concept what we are going to discuss purely concerned with aromatic system. What is aromatic system? Anything, say for example, the basic example of aromatic system is your benzene, which is a highly stable. All the aromatic systems are highly stable because of resonance delocalization, and it gets ultimately its stability because of this resonance delocalization of pi electrons. The next thing is electrophilic substitution. This reaction deals with electrophilic substitution into the aromatic system. Electrophile, we have 2 different types of attacking agents. One is electrophile, another one is nucleophile. We know very well. Electrophile is nothing but a species that carries the attacking agent when it carries positive charge. This is called electrophile. Naturally, since this attacking species carries positive charge, it approaches the aromatic system where we have the negative charge, excess electron, where we have the excess negative charge. Naturally, this is positively charged one, electrophile. This approaches, this attacks that particular center, and in turn substitution takes place. That we will discuss slowly. The next thing is, when a species carries minus charge, this we know that this is called nucleophile. One is electrophile that carries positive charge. Another one is nucleophile that carries negative charge. If it attacks the positive center, that is called a nucleophilic reaction. If electrophile attacks the negative center, this is called a electrophilic substitution reaction. Now we are going to discuss only electrophilic substitution reaction into an aromatic system. As far as the aromatic system is concerned, as I told you, benzene is the simplest example. We know very well. Benzene is the simplest example of aromatic system. The electrophile usually attacks the aromatic system because of electron rich system what we have in benzene. Benzene is usually electron rich system because of resonance delocalization of pi electrons. This movement of pi electrons inside the benzene ring gives ultimately the stability to this benzene ring. Therefore, benzene is highly stable. Benzene is electron rich because of the movement of this pi electron inside the benzene ring. Because of the electron-rich benzene, naturally the electrophile which carries the positive charge attacks easily the benzene. And in turn, after attacking this, in turn, it removes one of the proton from benzene and take that position. Now electrophile removed the proton and in that place the electrophile substituted, and we get finally the product. The product is like this. Substituted product. Electrophile substituted aromatic system we get finally. Therefore, this reaction is called aromatic electrophilic substitution reaction. Now, because of this electrophile attacking the benzene, substituting the proton what we have in the benzene by your electrophile, and finally the proton also removed, we get finally this product. How we get this carbocation, everything we will discuss when we are going to discuss the general mechanism of aromatic electrophilic substitution reaction. Are you clear? And one thing I want to tell you, friends, since we are discussing through online, we are not getting the direct contact. If you have any doubt regarding understanding the concept, regarding the understanding of the subject what I am teaching in the classroom, you are free to ask me in the Google Classroom. You can pass on your questions or doubts through your classroom. I will try to clarify your doubts then and there. This is my promise, assurance, don't worry. Anyway, I'll try to teach you in a simple manner so that you will understand thoroughly the concept. Whatever the subject I am teaching, be sure there is be attentive in my classroom. I'll try to teach you slowly and steadily so that you will understand the entire concept. Nothing to worry. This is my promise again. I repeat, the concept what we are going to discuss is aromatic electrophilic substitution reaction. As far as aromatic system is concerned, the simplest example taken here for discussion is benzene. Benzene is an electron-rich center. The electrophile attacks this particular corner or this particular position or this or this or this or this, because all the 6 positions are free to attack by this electrophile because of the similarity, because of the identical, because of your the uniformity in benzene. The electrophile can approach any of the corner, substituting the proton what we have in the benzene. Finally we get the substituted product. Therefore, this particular reaction in which the benzene is converted to electrophile substituted benzene, this is called aromatic electrophilic substitution reaction. And as far as the benzene is concerned, we have a number of electrophilic substitution reactions. The benzene usually undergoes a number of electrophilic substitution reactions. Say for example, nitration. And another one is very important reaction is sulfonation. Another one is halogenation. Another important reaction is alkylation. And one more important reaction is acylation. If nitro group, that is NO2 plus, attacks the benzene, as a result the product what we get is called nothing but your nitrobenzene. In that case, the reaction will be called as nitration of benzene, because you are introducing the NO2 plus, that is electrophile, into benzene. Therefore, this reaction is a nitration. Instead, if SO3H group, if you introduce into benzene, ultimately the product is sulfonated benzene. Benzene sulfonic acid you will get. In that case, the reaction will be called as sulfonation reaction, because you are sulfonating benzene. If you get by using either chlorine, bromine, etc., that is halogen in general, if you use in this electrophilic substitution reaction, say for example, let us assume you are using Br plus. In that case, the product what we get is brominated benzene, that is bromobenzene. That reaction will be called as halogenation. Specifically, since you are using Br plus, that reaction is called as bromination. If you use chlorine, Cl plus, the product what we get is chlorobenzene. In that case, the reaction will be called as chlorobenzene. If you use alkyl group to substitute benzene, the product what we get is alkylated benzene. In that case, the reaction will be called as alkylation reaction. If you use acyl group to substitute the proton of benzene, the product what we get is acylated benzene. Therefore, in that case, the reaction will be called as acylation of benzene. So, friends, I repeat, try to understand the concept. Simple thing. Benzene, if reacts with halogen, the reaction will be called as halogenation. If benzene reacts with sulfuric acid, concentrated sulfuric acid, in that case the product is sulfonated benzene, the reaction will be called as sulfonation. If nitro group, if you substitute the proton of benzene, the reaction will be called as nitration. If alkyl group you use to substitute the proton of benzene, that reaction will be called as alkylation. If on the other hand, acyl group, if you are using to substitute the proton of benzene, the reaction will be called as acylation. Anyway, these are the few important reactions as far as the benzene is concerned. Usually, the benzene undergoes electrophilic substitution reactions in these different ways. We have halogenation, sulfonation, nitration, alkylation, and acylation. Now we are going to discuss the very important thing, specific topic we are going to enter now. Now I am erasing this board. I am going to discuss the new thing. As I told you, if you have any doubt, you can ask me through Google Classroom, that is Google Classroom, regarding any of your doubts. I am ready to cooperate. I am ready to clarify your doubts then and there. I will try to cooperate. I will try to clear your doubts. Don't worry, nothing to worry. Now we are going to discuss the general mechanism of aromatic electrophilic substitution reaction. Remember, we are going to discuss the general mechanism. How the electrophilic substitution reaction in benzene proceeds. What are the different steps normally involved during the electrophilic substitution reactions in your benzene? Usually, if you take any kind of electrophilic substitution reaction, as I explained, nitration, sulfonation, alkylation, acylation, halogenation, etc., all different types of electrophilic substitution reactions proceed in general 3 different steps. Remember, I'm going to discuss the general mechanism. General mechanism of aromatic electrophilic substitution reaction. Step number 1. Step number 1 is approach of electrophile. Usually catalyst we use. Approach of electrophile into the benzene takes place. As a result, we get plus E H. This is the thing we get. After approach of this, after substitution of this electrophile E plus electrophile substitutes, that is removed the proton, what we have here in benzene, removed one of the proton, taking that particular position by this E plus. And finally we get, as usual, Nu catalyst. Yes, plus. Now come here. Step number 2. Once the product, what we call it as EH, this is the one we get in step number 1. The carbon, if the benzene ring carries this positive center, this is called a carbonium ion. This benzene with positive center immediately undergo a process called resonance stabilization. Resonance stabilization. This takes place like this. This will move here, making the shift of this positive charge from here to here. We get another resonance structure. Plus comes here and the minus goes here. In the next step, this comes here, making the positive charge to come here. We get one more thing. This comes here. Already we have this. And the positive charge comes here. The next step is, the final step is, I'm sorry, I have committed a small mistake. I'm extremely sorry, I have committed a small mistake here. Yes. Now it is correct. Plus H, yes. The first step is this moves here, making the shift of this positive charge from here to here. You get this resonance structure. Plus comes here, this goes here, E and H. The next step is, this comes here, making this positive charge to move from here to here. You get one more structure. Plus comes here, we have electrophile H. These are the things that usually takes place as a result of this delocalization, this movement of pi electron, internal adjustment of pi electron inside the benzene ring, shifting the positive from here to here, then from here to there, gives you different resonance stabilized structure as a result of this. You get finally this particular thing. Now we are in the final step. The step number 3, that is the last step, is removal of proton like this takes place. Plus we have here already the pi electron here, E is there. The removal of proton by your nucleophile that is connected with your catalyst takes place. The removal of proton is removed by your nucleophile, leaving the catalyst in its original form. You get this, making the bonding electron between the carbon and hydrogen comes here, then this goes here, this comes here. This, you get finally electrophile substituted benzene. Benzene now substituted with electrophile, you get finally. Therefore, this is your electrophilic aromatic substitution reaction. I repeat, try to understand the concept. As far as the general mechanism of electrophilic aromatic substitution reaction is concerned, whatever the type of reaction may be, titration, sulfonation, halogenation, alkylation, or acylation. In general, the different electrophilic substitution reaction proceeds via 3 different steps. Step number 1, attack of electrophile to the benzene ring takes place, gives you carbon with positive charge. Immediately, once this positive charge center is developed in the benzene, over benzene, resonance stabilization movement of delocalized pi electron inside the benzene ring takes place. As a result, the positive center circulated in a possible different ways. You get different stabilized structures, that is resonance stabilized structures. And the last step is removal of proton by your nucleophile, that is left in the first step takes place. And during this conversion, the substitution reaction, main reaction, the catalyst is finally removed in its original form. This is very important step, because in this step, the catalyst that is utilized in step number 1 in the main reaction is regenerated in its original form finally. These are the things, a few things to remember as far as your aromatic electrophilic substitution reaction is concerned. With this, I try to conclude my discussion in this limited time. We will try to discuss the main topic like nitration of benzene, halogenation of benzene, sulfonation of benzene, alkylation of benzene, acylation of benzene. Whatever we have in the syllabus, we will try to discuss one by one. This is about your aromatic electrophilic substitution reaction. I repeat, I'll try to give you the glimpses of the small, important points. I'll try to recollect your memory by discussing again just 1 or 2 minutes. I'll try to, that is, I consume to discuss this topic. Aromatic electrophilic substitution reaction. You are substituting the electrophile into the aromatic system, therefore this is aromatic electrophilic substitution reaction. Aromatic system is concerned, the simplest example that we have taken for the discussion is benzene. Benzene is usually, all we know that electron-rich system because of resonance stabilization, because of pi electron delocalization inside the benzene ring gives you the stability to the benzene, therefore this is electron-rich center. Since this is electron-rich, the electrophile feels easy to attack the benzene. You get finally the substituted product. Formation of substituted product using the electrophile is very easy as far as the benzene aromatic system in general is concerned. These are the 3 different steps normally involved in any type of electrophilic substitution reaction. As I promise you, I'll try to discuss in my next class the important reactions like nitration of benzene, sulfonation of benzene. In the next class, we will try to discuss that is bromination of, that is halogenation of benzene, alkylation and acylation of benzene. Thank you. With this, I am concluding this introduction. As I told you in previously, if you have any type of doubt, please feel free to ask me the questions via your Google Classroom. I am ready to cooperate. I am ready to discuss through your Google Classroom. I am always available to clarify your doubts. Thank you. Thank you all. Thank you for listening my lecture and videos. Thank you.